Okay, can. I think it's recording. Yeah, so sometimes, okay, I'll just for the video. Yeah, basically this is extra information. Complex numbers, we don't want. When we say two real and distinct, we focus on the real, meaning these two answers are, for example, all real, no imaginary, don't have the I. Then b squared minus 4ac more than equals to 0. Okay, then sometimes the questions may play around with English and they'll say, give me the range of values of whatever letter that has at least one root. At least one in this case will be b squared minus 4ac more than or equals to 0. Okay, have to be careful with that. It's not always just more than 0. Right? At least one means what? At least one means one root only or two roots. You can't have more than, maybe also 3 roots or 4 roots or 5 roots, but we know that's impossible because it's a quadratic. So it's one root only or two roots only. What's one root only? B squared minus 4ac must be
equals 0.
How about two roots?
More than 0.
Then when you see this or here, you have to combine equals 0 or more than 0. Well, that's just more than or equals to 0. This symbol. Okay. Yeah. My questions are very simple. I never play around with English. I just give you very simple cases. More than 0, equals 0, less than 0. That's all. And you understand already. Very good. Okay, now let's move on to part 5, something new. Here they tell you, you start off with a quadratic expression. Okay, let's read the question first. Find the range of values of h for all real values of h for which satisfies the following inequalities. What do I mean by satisfies the following inequalities? Let's look at part A. We start off with blah, 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 something x squared, something x and a constant, less than 0. Less than 0 here means the quadratic is negative. So sometimes the question will phrase it as, find the range of values of h such that minus 3h minus 1x squared plus 4x plus 2h minus 3 is always negative. Or just is negative. Okay, then how? So to explain this question, right, I need you to visualize what's going on. Let me draw a table. So below, I need to draw a table. Let me just plan this out. I need a more than 0. I need a less than 0. Draw a line. Draw a few lines. Then we got b squared minus 4ac. 3 different cases. Less than 0, equals 0, more than 0. When b squared minus 4ac is less than 0, how many roots again?
When b squared minus 4 is less than 0, then no roots.
Okay, so 0 roots. Then if it's equal to 0, how many?
One root.
One root.
Yeah.
And more than 0 is?
Two roots.
Exactly. So you see the pattern 0, 1, 2. Okay, so for the first case, when a is more than 0 for a quadratic, let's say in the most general form, y got ax squared plus bx plus c. I think you know, when a is more than 0, how does the curve look? Is it happy or sad?
Happy.
Okay, then when, of course, the other case will be sad. So let's think about how the picture would look. Y-axis here, x-axis here. If you have a quadratic and a is more than 0, you know it must be happy face. But there are three possibilities. Either like this, or like this. Can you see what's the pattern? The first example, how many intersection with x-axis?
2.
Second example, how many?
1.
Then the last one, how many?
No, don't have.
0. Exactly. So now we are at the case where 0 roots. So which graph do you want? First one?
First one.
Exactly. Okay, can. Okay, so that's the first case. You need to have this picture in your mind. So when so what else do you notice about this? The y equals blah blah blah. You notice that it's always above x-axis, which means that the y for every single point here, there's an x comma y, right? X comma y. What do you notice about the y coordinates? They are all what?
Positive.
Exactly. Yes. So it's always positive. Okay. So every time you hear a question say always positive, or you see some quadratic more than 0, you must think of this picture, which means a is more than 0 and b squared minus 4ac is less than 0. You should have the picture pop up straight away in your head and then after that you convert into the math. This is the math, a more than 0. This is the math, b squared minus 4ac less than 0. And then you work with the inequalities. Okay, next picture. Of course, I think you know this already. X-axis, y-axis. How does the curve look?
One point is touching the x-axis.
Happy or sad face?
A happy face.
Because a more than 0. Okay, so it will look something like this. Okay, then the next one. Oops. Let's just finish up. Y-axis, x-axis, 2 roots. So it must be a bit lower, like this. Okay. Then for the a less than 0, it's basically the same thing, but you just reverse it. Okay, let me just quickly draw it in for you. Copy down the x and y axis a few times. Okay, so this one, a less than 0 must be a set face. B squared minus 4ac less than 0 means no intersection with x-axis, 0 roots. So how? Maybe you can try drawing the 3 curves like this. Correct. One time. And yes, exactly. So cut 2 times. Okay, let me just correct. Yes. Okay, and what else do you notice? Which one is always negative?
Why?
Left, middle, right. Left, middle, right.
Which one is always negative?
Correct. Y coordinate is always negative.
Left.
Exactly. So this is always negative. So again, similar to the always positive case, every time the question says always negative, you need to think of this picture. And then you must convert into this inequality and this inequality. Okay? Can I move on? Okay, so now we can answer the question. Here, when I say satisfies following inequalities, let's just look at part A. It means that this quadratic must be less than 0. It's always negative. It's always negative means you must be in this case, which means A must be less than 0, b squared minus 4ac less than 0. Clear about this?
Yeah.
And also what that means is we actually need to, let me just copy down the question first. Okay, just draw a quick sketch. You don't need to draw the sketch. Just have it inside your head can already. Or less than 0 means you must have this picture, which implies that your coefficient of the quadratic A which is minus 3h minus 1, it must be less than 0 because set face. And what else about the b squared minus 4ac?
B squared minus 4ac is less than 0.
Why less than 0?
Because no points are touching the x-axis.
Yes, which means 0 roots. Or yes, same thing as no intersection.
Wait, so the minus the a, you know that the a is negative because it's less than 0.
No.
Like why? Yeah.
Because always negative translates into this picture. Right? Is there any other possibility? I already listed down every possibility. This is the only possibility for a quadratic graph to always be negative, right? Then what do you notice about the shape? Happy or sad face?
Sad face.
Sad face, then it must be a less than 0. That's a rule, right? Okay, that's the reason. It's because it's a sad face. It's not because you're not following this inequality. No. Wrong. That's wrong reasoning. It's because it's a sad face. Here. Picture, sad face, a less than 0. Can?
Okay.
Can later we'll have happy face. Later. Then it will be more than 0. Yeah. So now we got 2 inequalities to work with. Let's just deal with the first one. So minus 3h minus 1 less than 0. Let's try to solve this. So 3h plus 1 will be more than 0. I just multiply by -1 on both sides and flip the sign. Then h must be more than -1/3. Okay, box it up. I'll call this rule number 1 or equation 1, inequality 1. Then now we need to deal with the second case. Copy, paste. Let's solve it. Yeah. So same thing again. I think you know how to solve already. I noticed straight away that here got 4, here got 4. I can divide by 4 on both sides. So I will be left with 4 minus 1. Don't need to write the 1 lah. Minus 3h minus 1 times 2h minus 3 less than 0. Expand. So negative 3h times positive 2h minus 6h squared. Minus 3h times minus 3 positive 9h minus 2h plus 3 less than 0. Distribute the minus sign. Actually, maybe you can combine these two into 7h first. I'll get 4 plus 6h squared minus 7h minus 3. Did I do it wrongly? I hope I didn't do it wrongly. 4 minus 3 is plus 1, less than 0. Use calculator because I am lazy. I think it's 6 and 1. Okay, so I will be able to get h minus 1 times 6h minus 1, correct? Can now? Okay, good. So now you can solve. Quadratic. The two roots is 1 and 1/6, correct?
Yeah.
Wrong. What's wrong?
1 should be on the right side, and then the 1/6 should be on the left side.
Yes, correct. Possible careless mistake. Okay, so less than 0, then what do you do? Take note, just now we started off with what? We started off with the question less than 0. Okay, some generic quadratic expression less than 0. Now we end up with another less than 0. Don't stress out about the always negative, always positive here. For this case, we are always assuming that there will be this picture here. It will intersect h-axis 2 times. Then you just use the method that you have been solving so far from section 1 to section 4 and then you answer accordingly. So what's your answer, final answer?
I want to say is h more than 1/6 less than 1.
Yes, very good. Exactly. That's it.
But
sorry?
No, never mind.
This is inequality 2. Remember there was an inequality 1?
Yeah, okay. That's just what I was gonna ask. Okay.
Yes. So now you need to satisfy both inequalities. But of course, if you remember how to satisfy both inequalities, what you're supposed to do is draw a number line. Let's call it HR. Then let's just label some of the points. There's a negative 1/3. There's a 1/6. There's a 1. So the first inequality tells us h less than negative 1/3. So you draw a picture like maybe something like a circle like this, empty circle because this is strictly more than, and more than, right? So you point towards the right. And here 1/6 to 1 means you have an empty circle at 1/6. And then you go all the way until 1, empty circle at 1. Then you want to find a point of intersection between them. Can you see this is the overlap between the two inequalities? And you realize that, for this question, it just happens to just be equation 2, nothing special. Okay, so that's your final answer. So even if you forgot about the part 1, sometimes it will be okay to just take the equation 2. But technically, you should also check this inequality. Okay, the a less than 0. Right, remember the a less than 0 here? Yeah. Okay, can. So yeah, so therefore, sorry, maybe I should put it below the inequality. Therefore, 1/6 less than h less than 1. That's your final answer. Can?
Can.
Okay, good. Let's try another example. Part B. Wait, let me copy down this inequality. Copy and paste. Over here. Okay, this is part B. 3h minus 2 times x squared plus 1 plus 4x. You want it to be strictly more than 0. So this is what we are starting off. You start with more than 0. Okay, start with more than 0. So it means that you're expecting what picture? You're expecting this picture. Like this. Correct? Floating above the x-axis. Okay. Oh, by the way, it is impossible for you to have a set face that's always positive. This one. Do you know why?
Why?
Because some students tell me, hey, Ken, you see, it's floating above, so all the y coordinate is positive. But actually, what they fail to realize is,
yeah, it will, okay.
Yeah, it actually extends all the way, right? So it will no longer, it will actually become 0 or become negative. So it doesn't satisfy the always positive rule. Okay, so this is impossible. There's only one case. You need to get this picture inside your head immediately. Always positive picture. Can?
Okay.
Yeah. Okay. Can. Then what's so special about the picture? Happy face. So A is
more than 0.
Here, let me ask you, is the A just 3h minus 2?
No.
Okay, we don't know yet until we expand the bracket. And after you expand the bracket, actually it is. So I'm just going to write down the generic A. Maybe I'll write down coefficient of x squared. Also, because it is floating, meaning they have 0 roots. Like a plant that has no roots is floating above the ground. Very scary. Then b squared minus 4ac must be less than 0. Okay? Okay, let's begin. So this question, we start off with the quadratic. We want to expand it first. Instead of multiplying term by term like this, what I'm going to do is I'm going to lump this 3h minus 2 together as one single term, and then I multiply to the x squared, multiply to the plus 1. So I will get 3h minus 2 bracket x squared plus 3h minus 2 times 1. Does this make sense?
Yeah.
Can then plus 4x more than 0. You realize that h is a constant, times 1 a constant, so everything here is just a constant. So actually, if I just want to make it super neat, I can write it as the quadratic plus the 4x, the linear, power 1, and the constant 3h minus 2, more than 0. Now, can you tell me what's my A? Coefficient of x squared.
Your A is 3h minus 2.
And your B is?
4.
And your C is?
3h minus 2.
Okay, very good. So now we can start dealing with the inequality. So A, you want it to be, okay, maybe I write down. Yeah, I'll just write this down. 3h minus 2, it must be, what is it again?
More than 0.
Right, I forgot to write down here, more than 0, sorry. More than 0. Then you solve for h, will be more than 2 over 3. First inequality to satisfy. Rule number 1. Then what's the second rule? Maybe I'll just write down here, happy face. Yeah. Then what's the second rule you need to satisfy? This one. B squared minus 4ac less than 0, so we can do that. B squared minus 4 times A times C less than 0 because no roots. Okay, then again, you can just divide by 4 on both sides, and you get 4 minus 3h minus 2 times 3h minus 2, which is just 3h minus 2 squared. Oh, by the way, you remember that I forget if I talked about this. A plus b bracket square equals a squared plus 2ab plus b squared. You remember this?
Yeah. I think you talked about it in your video.
Oh, okay. Yeah, you still need to remember this. Okay. Later on, this power 2 is going to increase to power 3, power 4, power 5, power 6. And there's still a formula to remember. It's called binomial expansion. Okay, it's the next topic in AMAX. Okay? So it's good to remember the easiest case. The easiest case being these 3 cases. It's from Sec 2 Max. Okay, let's just expand this. So we get 4 minus bracket 9h squared minus 2 times 3 times 2 is 12h plus 2 squared is a 4. Less than 0. Distribute the minus. Minus 9h squared plus 12h minus 4 less than 0. Anything special? 4 minus 4 cancel off. Anything else special? there's a negative sign here. So maybe I can times -1. So 9h squared minus 12h less than 0. What else? I can divide by 3 throughout. So 3h squared minus 4h less than 0. Anything else? Common factor.
Yeah.
H, right? So you get 3h minus 4 less than 0. How to solve? H. Happy face. Happy because there's a positive coefficient here. Then you get 2 roots. 0, 4/3. You want less than 0, so it must be 0 less than h less than 4/3. This part here. Okay? Okay, good. That is your second inequality. Then now you have to draw picture. Sorry, I mean, what do you call it? Draw the inequality. So h here, you label all the critical numbers. We call them the critical numbers, critical values. 2/3, 0, 4/3. So 0 here, 2/3 here, 4/3 here. H more than 2/3 means you draw a circle, empty circle like this, and then you move towards the right. Right? More than 2/3. Then 0 less than h less than 4/3 means draw empty circle at 0 all the way until 4/3. Now this question is yes, exactly. You find the intersection here. Correct. So it's 2/3 less than h less than 4/3. That's your answer. Okay, so it is necessary for you to know this rule. Happy face must have the coefficient more than 0. Okay. In this case, if you gave the answer as 0 less than h less than 4/3, your answer will be wrong. It will be wrong. It's not the final answer. You need this. Okay? Do you think you're ready? Do you need me to go through more questions, or you're ready to try? My plan is to go through A, B, C, D, then E, F, G is homework. Or maybe I think I'll just stick to that plan now. C and D, maybe we can do together. You tell me what to write. Let's start with C. You tell me what to write. Yeah. Let me start a new page. Hold on a sec. Where's my... Okay, how? Less than 0. Picture. How does it look?
Less than 0. Less than 0 means always.
You can sketch for me, like on the side. Let's say I have x-axis, y-axis. How does the... Oh, sorry. Have you drawn it?
No, I haven't.
You want a quadratic, happy or sad face? There is always less than 0.
Sad face.
And no intersection with x-axis. Good. So what can you conclude? A must be
negative.
Less than 0. And b squared minus 4ac?
B squared minus 4ac is less than 0.
Exactly, because here got 0 roots. The a less than 0 is because it is a sad face. Then let's deal with the first rule. Because sad face, therefore a less than 0. So what's my a?
H.
Maybe, yeah, exactly, it's h. But maybe it's better if I just simplify this first. Can you simplify for me?
Sure. H.
Hx squared. Sorry, sorry, your audio got cut off. Mic test, can you hear me? I cannot hear you.
Yeah, I can hear you.
Okay. Okay, I can hear you now. Good. You were saying?
Hx squared plus 16x plus 16h plus 16 times 3. What is 16 times 3?
48.
Okay, 48.
Okay, good. Yes. So you were saying h must be the a?
Yeah, h is a and is less than 0.
Very good. That is your rule number 1 you must satisfy. What else? What other rule do you need to satisfy? And you also need to satisfy this rule, b squared minus 4ac less than 0. So write down the b squared minus 4ac less than 0. What is it? Just precise.
16 square minus 16 square minus 4 times h times 16h plus 48.
Continue.
Less than 0.
Very good. Okay, then now you can temporarily ignore the h less than 0. Then just focus on the inequality. Okay, 16 square. Wow, let's use a calculator for this.
256.
256 minus away 4h bracket 16h plus 48. Okay, you continue. You tell me what to write.
256 minus 64h square minus minus 192h. And then use calculator. Wait, do you factor first or use calculator?
Just use calculator, can already.
Okay, can.
I mean, yeah, yeah.
But you want change to what? Change
Oh, sorry. You actually need to factorize because you don't want to just solve for h, right? This is an inequality.
Yeah.
You need to draw a picture. Yeah, so maybe you could at the side as a working, you write this down equals to 0. Then using a calculator, you get what? H equals. Careful, what's your A, what's your B, what's your C?
H equals to 1 or H equals to -4.
Exactly. Okay, so that means that on the graph here, right, you have to draw h-axis, draw happy face, 2 roots. So 1 and -4, correct?
No.
Yes, it's our trick question. Your -4 should be on the left, okay? I always trick my students. Okay, good. -4 on the left, right? -4 is smaller than 1. Yes, so it should be on the left. Okay, then less than 0.
Yeah.
Continue.
Okay. Yeah. Wait, can do this one divide by -64?
Can. If you want to do it manually, of course. Oh, by the way, maybe I should also mention this. After you get the 2 roots already, I'll leave that to you, dividing by -64. You got h minus, you can factorize as h minus 1 and h plus 4, right? Based on these 2 answers.
Oh, yeah.
But you realize it's not exactly the same, right? Because here you see h times h gives you 1h squared. But here you got a -64 h squared. So actually you just need to plug in an extra -64 in front. Less than 0. You can go and verify this on your own. You multiply out, you will get back the same answer. Okay?
Okay.
But the -64 here, oh wait, sorry, I realized something. Here is a negative coefficient, right?
Yeah, so set face.
So it should be set face. Sorry, I forgot. Should be a set face. This is the first time that you've seen a set face, right? For this kind.
Yeah.
But usually I just stick to happy face, but I think you can handle it, so I'll just talk about it. Here, whenever you got a negative coefficient for the quadratic, you can also draw a set. You can draw a set face instead of happy face, but you want less than 0. So which part of this curve is less than 0? There are essentially 3 parts, right? Let's say a gray part, the brown part, and the green part. Which parts of this curve is less than 0? Gray, brown, green.
Gray and green. No.
Exactly. Correct. Yes, gray and green are less than 0, below the h-axis. Then we want the shadow. Okay, you imagine like there's a bright sun. Okay, maybe more like a torchlight. Torchlight. Okay, torchlight. Very, very bright torchlight in the middle. And it's casting a shadow. So the shadow is now here. And then you cast shadow, 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 then the shadow is here. So I'll just highlight the shadow here and here. The shadow is your answer. So what does it mean? It means h is less than -4 or h is more than 1. Okay, must be a or, not n. Must be a or. Cannot be an n.
Yeah.
Of course, if you find this a bit complicated, what you can do is you can just times -1 on both sides. So you get positive 64, h minus 1, h plus 4, more than 0. Okay, maybe that will be easier. Then you can just draw a happy face, then more than 0. So this part and this part. You'll get back the same answer. H less than, it's -4 here and +1 there. You get h less than -4 and h more than 1.
Okay.
Okay. Okay, so this is your inequality number 2. Then you need to satisfy both inequalities. Let's just recall what's inequality number 1. Over here. Then how? How do you, what's the final solution? What do you need to do?
H less than 0 or h more than 1.
Not really.
Okay.
I go through. Can? Or do you want to try?
No, you go through.
I go through. Okay, can.
Yeah.
So how do you satisfy both of these inequalities? Again, draw the h-axis. Label all critical numbers. These are the critical numbers on the axis. A -4, a 0, a 1. We have less than -4, more than 1. So let me just color code it in, I don't know, blue color. Then less than -4 means circle to the left. More than 1, circle to the right. This is my equation 2. Sorry, inequality 2. Then h less than 0, let's just use black. It'll be this black circle all the way to the left. Then how do you solve an inequality? What you're supposed to do is look at this diagram now and find the intersections, which I think you can tell is this region here and this region here as well. If there is no intersection on its own, then it is also part of the solution.
Okay.
Possible values of h that satisfy both rules, rule number 2 and rule number 1, or both inequalities. So the final answer should actually be h strictly less than -4 or h more than 1. You put down an or when the regions are not connected. Like there's a chasm, there's a gap in between. Then you put down an or. Can? Sorry. Sorry. Yeah, h less than -4 or h more than 1. Then that's your final answer. Can?
Yep.
Oh, I realized that it's actually exactly the same as part 2. So and let's say I had a different scenario. Let's say this is extra. Oops. Let me just put it on the same page. Let's say it's a extra piece of information. Let's say I start you off with h less than let's say let me think a bit. H less than 1, that's your inequality 1. And then you have h, let me think a little bit. H less than -1 or h more than 0. Let me change this to a 2. And h more than 1. What's your final solution if you want to satisfy both inequalities?
I think it's h less than 2. Wait, h less than 2 or h minus, I mean h more than 1.
No. What you need to do is draw a picture. Okay, again.
Okay.
H axis. Label all critical numbers. A -1, a 1, a 2. Rule number 1, h less than 2. Draw a picture. Empty circle all the way to the left. Why empty? Because this is strictly. If you see an equal, then you need to shade in the circle. I think this is from Emacs. Yeah, then h less than -1, circle all the way to the left. Or h more than 1, so circle all the way to the right. Where's the intersection? Can you shade in for me? And maybe I need to make my arrow a bit blur. Ah, yes, that's the intersection. Okay, so it's actually this region here as well as this region here. So your final answer is actually, if I can just modify h less than -1 or why? Why do I put or? Because there is a gap. It's not continuous. Then you have 1 less than h less than 2. Okay? Basically, I combine h more than 1, h less than 2. 1 less than h less than 2. Okay? Okay, you may encounter this. I'm not sure. I can't remember. I can't remember if there's such a complicated inequality you need to solve. But let's just move on. Part C done. Let's move on. Part D, last one. Then the rest will be your homework already. Part E, F, G. Let's look at part D. Let's just go through together. You tell me what to write, then we can. I'll write it for you. I think it's a bit faster that way. Okay. Let's go. How?
Picture first. So more than 0 means always positive. So a must be more than 0. And then b squared minus 4ac is less than 0. And then so minus h plus 1 more than 0.
Minus 4h plus 1. What was it again? More than 0. Okay, good. Solve for h.
Then h is less than 1/4.
Yes.
So that's your inequality number 1. Then 3h plus 1 square minus 4 times negative 4h plus 1 bracket, then h plus 3.
Yeah.
Less than 0.
Yes. Okay, then we can ignore everything and just focus on inequality. Expand.
9h square plus 6h plus 1 then negative 4, then
Bracket.
times 4h square.
Positive or negative?
Negative.
Negative 4h squared.
Then minus 11h.
11? How do you get 11? 4 times 3 is 12.
The 1 times h.
Oh, you did it immediately. Can. Minus 4 times 3 is negative 12 plus 1. Then you get negative 11. Okay.
Then plus 3.
Close bracket.
Yeah.
Less than 0. Copy. 9h squared plus 6h plus 1. Distribute.
Plus 16h square plus 44h negative 12 less than 0.
Good.
And 25h square plus 50h square.
Okay, just h, no square.
Yeah, sorry. Then negative 11 less than 0.
Exactly.
Then calculator.
Yes.
5h minus 1 And then the other one is 5h plus 11.
Very good. Okay, then you can draw H. Happy or sad face?
Happy face. Because
Happy face.
more than 0.
Positive 25. Two roots. What are they? Negative.
Yeah.
Negative must be on the left.
Yeah.
Smaller on the left. Okay, then final answer.
Then cause less than 0. So yeah. Then the second inequality is H more than 11/5 and then H less than 1/5.
Oh,
And then what's the first inequality again?
let's see, what is it? H less than 1/4. I'll just copy it over here so it's convenient.
Okay.
Then what do you do?
Draw number line.
Draw number line H. Then
put the 3 points.
what are they? Negative 11/5. 1/4, 1/5, which is smaller?
1/5.
5 first, then 1/4. Yes.
I almost said 1/4, by the way. You almost got it. Okay.
Yes.
So
can you draw the picture? This one you must draw on your own. Try. Draw the circle, the line, the circle. Correct.
Yeah.
It's fine.
Okay.
Okay, so that's the intersection, right? In the middle. This region here. Yeah, okay, I get what you're doing. Yes, it's fine. Let me just draw it nicely. Circle until, until 1/5, then circle, and all the way to the left. Intersecting region is this part here. So yeah, don't need to draw so many lines. You can see it can already. So the final answer will be negative 11/5.
Yeah.
Less than
H less than 1/5.
Exactly. Good. Okay, you got it. You can do the rest already. Okay, homework. Yeah. Part EFG will be your homework. Okay. Okay, let's move to the next section. Now it's 9:48. I still got 1 hour plus. Okay, next section. Hold on a sec. Let me copy down the question from my. Okay, the next section is about showing or proving questions. Now, this is the kind of question that actually, if you're going into engineering, you won't be asked to do so much, but it's in the syllabus, so I'll just explain it. It's tested in AMAX. It's quite simple. So the key thing you must remember is anything to the power of 2 is always more than or equal to 0. Makes sense, right? Because if you draw the graph of y equal x squared, there's no negative part. It's always above or exactly at the x-axis. Okay? So x squared more than equals 0 for all real x. Meaning for all real x means any number you put inside x, you raise power to more than or equal to 0. In fact, you can generalize to x to the power of 2n is more than equal to 0, where 2n means even number. N must be more than 0. So a positive even number. So power 2, power 4. So example, 2n would be 2 or 4 or 6 or 8. Right? Raise power 2, raise power 4, raise power 6. Because you can always, like for example, if you have x to the power of 6, it's really just x cubed raised to the power of 2. So again, you get back to anything to the power of 2. Anything power 2, more than or equal to 0. Must remember this rule. Can you remember?
Yeah.
Can I? Okay, now let's start with the question 1. Okay, first type of question. Show the expression is always positive. Just now we started off by telling you it is positive. Then we ask you what's the range of values of k. Now we are not asking you to find the range of values of k, We want to show that for all values of k, show that the following quadratic expression is always negative. So it means that if we started you off with like, let's say the part A, I'm copying down the part A's quadratic, and then I say less than 0, I ask you to solve for k, the range of k. The answer is k. The answer is all values of k, all real values of k. Okay, so far I have not given you question that has a solution being all real k, all real values of k. Because they are usually not gonna test you on that. Okay, can if this is what we started you off with, the section 5, this is section 6 by the way. Section 5, if I started you off with this inequality, and then I requested for you to find the range of values of k, the answer will be all real values of k. Now I'm asking you to work backwards, starting with, sorry, maybe I should draw an arrow like this. Now I'm just reversing the direction of the arrow. I'm starting off with all real values of k. I want you to show that this quadratic on the left will always be less than 0. This is what we call a proof question. Can you understand the concept?
Wait, why do you know this?
Where? Oh, given by the question. For all values of k, it was given by the question.
Oh, for all
It's
values.
given by sorry, I didn't write that. Given by question.
But then, what does this mean?
Where? First, show the expression is always positive or negative. So we need to prove that the expression is always positive or always negative. I think it's easier if I just do the question. Basically, you need to show that this guy will always be less than 0. Let me just demonstrate. I think it will be clearer. So let's start with part A. Here. This is part A. Do you remember something called completing the square?
Oh yeah.
Yes, definitely. I saw your Emacs paper. You were doing completing the square. You understand? Like, you just have to add and subtract half the coefficient of x squared. But this time there are letters. So maybe I just do a quick recap. Let's say you got x squared plus 6x plus, let's say, I don't know, 7. How do you complete the square? What you do is you take x, you plus, you take the 6, you divide by 2. What do you get? It's a 3. Close the bracket, square. Then you minus away 3 squared. Copy down the constant plus 7, right?
Yeah.
Correct? Okay, that's the idea. But now we're going to apply it to the more special question here where there's a minus 2k. So I don't like the negative sign here. So I'm going to factorize it out first. So I'm going to factorize out the negative. I get x squared plus 2kx plus k squared plus 1. Correct?
Yeah.
Sorry. Is this confusing? Let me just move it aside. I change color. Yeah. Okay. So negative sign always in front. I'm going to change to square bracket now. We're going to complete the square for this one. So what do we get? X squared just reduced to a x. You see plus sign, just copy down plus sign. You see coefficient of x, divide by 2. So 2k divided by 2 is?
K.
Just k. Close the bracket, square. Minus away that same constant, k.
K square.
Okay. But then at the side, the constant here, there's a plus k squared plus 1. So you just copy and paste.
Yeah.
So plus k squared plus 1. Magically, coincidentally, it was by design. Minus k squared and plus k squared cancel off. Right?
Yeah.
So therefore, we are left with negative sign, square bracket, x plus k square plus 1. Can you remind me again what is so special about x squared with relation to 0?
X square will always be more than or equal to 0.
Exactly. Good. So how about x plus k squared? Let's study this. X plus k. It's just anything, right? It's just some number. Then you square it. We know it must be always more than or equal to 0. Agree?
Yeah.
Okay. So look at what I'm doing. I draw a squiggly line. This is what we started off with. I complete the square and I simplify into this format. Then I put a break. I pause. Then I take whatever is inside the brackets. Can you see? Inside the square bracket. And then I try to analyze it. I realized that this first component here always more than equals 0 by just a simple fact. So far clear? This part?
Wait,
This part, okay?
say again the last part.
Sorry?
Say again the last part or like what you said.
Okay. I was summarizing what I was doing.
Okay.
Let's so I started off with this quadratic. I complete the square to get into this format. This part, okay?
Yeah.
Then I now want to show that this guy is less than 0. That's the question. In other words, this guy is less than 0. So what I do is I analyze this fellow part by part. And I focus on the content that is inside the square brackets. More specifically, so far, okay?
Yeah.
So far, yeah, okay. Then I analyze it part by part. So the first part inside the square bracket is x plus k bracket square. Then we conclude that it is more than equal to 0. This part, okay? But that's not the only component of this expression inside the square bracket. There's also a, what do you see? There's also a
+1.
+1. So what we do now is we're gonna add 1 to both sides of this inequality. So we get x plus k bracket square +1 is more than or equal to 0 plus 1. Of course, that's just 1. So can you tell me what's so special about +1?
+1 means that
okay, this one you need. It's a very simple fact, but you remember the goal of the question. We want to show that it's less than 0. So how about we conclude that, do you agree with me with this conclusion? 1 is strictly more than 0.
Yeah.
Obviously, right?
Yeah.
But even though it's obvious, to be able to come to this, realize that this is important, that's the difficult part. Okay, so what we can conclude now is, if let's say, for example, you have 5 more than 4 more than 3, you agree with me that 5 is more than 3?
Yeah.
If I start off with this one, I can conclude 5 is more than 3. So same thing here, but with algebra, I can say that x plus k bracket square plus 1 must be more than 0. Agree?
Agree.
Okay, but wait, the actual original expression is negative square bracket of this guy. Negative square bracket of this guy. How do you go from the original to the negative square bracket version? You simply multiply both sides of the inequality by
-1 less than 0.
Then it becomes less than 0. Then we are done. Okay, or in other words, this guy is exactly equal to the original question. So minus 2x squared minus 2kx minus k squared minus 1 less than 0. Should. This is what we call a proof question. Just like in Emacs, when you're proving this angle is equal to the angle, or proving congruent triangles, that kind of thing. Ken? Have you seen this kind of questions?
No.
It's basically what you do in university mathematics. Like if you're in math course, but engineering, you don't need. If you're in engineering or computer science, you don't need to know this. Okay, but this was in AMAX. Sec 3 kids can do this. One of the most difficult questions. Type of questions. Ken? Ready? We try our next question. Ken? Okay, next question. Copy down. These questions we really need to spend a bit more time planning. Yeah, let's just do this. So for part A, part B, and part C, it's all trying to prove that it's less than 0. Okay, prove that it's negative. So what should I do? What was the first step that I did? First step.
Complete the square.
Okay, then yeah, complete the square. Then after that, you analyze it part by part, piece by piece. So remember the goal, we want to show that this entire thing is less than 0. But this is a bit too difficult, so we complete the square. That's the first step. Maybe I should write this down. Let's do that. So complete the square. I noticed that there's a negative coefficient. I am very scared of negative signs.
Yeah.
So I like to factor out the negative square bracket. You start to see a pattern. Got negative square bracket. Why do I have a negative square bracket? It's because I eventually need this less than 0 times -1 on both sides. But you can think about it later. So we get plus k squared minus k plus 2, right? Then equals to negative square bracket. Complete the square for me.
X squared.
X. Oh, you want to add and subtract slowly? Okay, can. X squared.
Wait, never mind.
Skip it. Just directly factorize. Can you do it? Open bracket x.
X minus 1 minus k over 2 square.
I prefer to just not simplify it and rewrite it as 2 minus k over 2. Okay, because there's no point. I'll just tell you straight up, there's no point. This is just 2 minus a number, then you divide by 2, another number. At the end of the day, this is just a number. It is not so important. What is more important is that we can close the bracket and raise this to the power of 2. So it becomes anything to the power of 2. Correct? What do you know about anything power 2?
Always more than or equal to 0.
Exactly. That's the main point. We don't care about the tiny details here. Okay, but this one is because I planned the question. So I'll just tell you, you don't need to simplify as 1 minus k over 2. Or actually, you need a minus sign to distribute in. If you really want to simplify it, it would actually be x minus 1 minus k over 2 with brackets. Then you distribute the minus, so it's x minus 1 plus k over 2 bracket square. But there is no point in simplifying it into this format. Just remember the generic formula for completing the square. Take the coefficient, divide by 2. Okay? Then you still need to minus away that same guy, 2 minus k over 2 bracket square. Agree? Yeah, can. Then what happened to your plus k squared minus k plus 2?
Just
copy. It's just there, right? Copy and paste it.
Yeah.
Okay. Continue. Now this one is important. You need to actually expand. Okay, so maybe it was a good idea if we simplify this. Okay, I'll just do it at the side. 2k minus 2, 2 minus k over 2 bracket square. It's actually 2 minus k square over 2 square. Correct? Expand the numerator, we get. Oh, by the way, did you know that a minus b bracket square is the same as b minus a bracket square?
Sure.
Like 1 minus 7 square and 7 minus 1 square. This is just a negative version, right? You square it, you'll just get 2 positive. They're the same, right?
Yeah.
So I can actually rewrite the 2 minus k as k minus 2. Then use the formula. I think it's easier. So now 2 squared is 4. Then you get k squared minus 4k plus 4 over 4. Can?
Yeah.
Simplify a bit more. We get 1/4 k squared minus 1k plus 1. Is that okay?
Yeah.
Okay, good. Then we can sub in. So negative square bracket, copy down this. Minus away, what was that quantity? Minus away this thing here. So just change to a minus sign now. So negative 1/4 k square plus k minus 1. Plus, minus, plus, minus, plus, minus. Just times -1 because of the minus sign here. Is that clear?
Yeah.
Okay, then don't forget the plus k square minus k plus 2. Okay. Okay, then we continue. Yeah, no space. Let me just move this here. Continue. Yeah, so now we can start to combine, collect the like terms here. So let's see what we get. Minus 1/4 plus 1. That's just a positive 3/4 k square. Plus k minus k. Cancel off. Minus 1 plus 2. That's just a plus 1. Agree?
Yeah.
Can Okay, then don't forget the something square, anything square. And there's a plus sign here. Don't forget the square bracket. Don't forget the minus sign. So far, okay?
Yeah.
Okay, what is our goal again? What's the question asking you to do? Show that this guy here is less than 0.
Yeah.
Always negative. Which means that you want to show that this guy here is less than 0. Is that obvious to you? This is less than 0?
Yeah.
Why?
Cause inside it will always be positive. Inside the square bracket, then
Yeah.
that's negative.
And how about this part here? Is it positive or what is it? You remember we want strictly less than 0. Here the 3/4 k square is more than or equal to 0. So there's a chance that it's equal to 0. Then how? It's not strictly less than. After you multiply negative, then you become less than or equal to 0. Then how? See, you analyze it part by part. Okay. This first part, more than or equal to 0. You know that. 3/4 k square also more than or equal to 0. What if you pick a special value of k such that this is equal to 0 and this is equal to 0? Then you times negative. Oh, it's equal to 0. You don't get strictly less than 0.
Got plus 1.
Because of the plus 1. Yes. So let's analyze it part by part. Draw a squiggly line like this. So the first guy, anything square is more than or equal to 0. Second guy, 3/4 k square, we also know that it is more than or equals to 0. So if I just add these two inequalities together, like a bit like chemistry, if you study chemistry, you balance equation, you add them together, you get 0 plus 0, more than or equal to 0. But there's also a plus 1. So that means that let me zoom out first. I can take this same thing by plus 1 to both sides of the equation. I will be able to get more than or equals to 1. Maybe I use red pen. Plus 1, which is strictly more than 0. I think you can see the pattern, right? From the previous question. 1 more than 0. This is very obvious, but it's very important. What do we conclude now? We conclude that the left-hand side here is strictly more than 0. But we actually need the negative square bracket version. So multiply by -1 on both sides. What do we get?
Less than 0.
Exactly. Strictly less than 0. Never will it be equal to 0. Essentially, this is just the original question.
So
I'm too late. Original question. Less than 0. Okay?
So all the working must be shown.
You can skip some steps if you find them obvious, but I may question you as to why you know this is true. You need to explain a little bit.
Okay.
Better to show, better to show. Okay, then shall we try another one, or do you want to try as homework?
I'm okay with anything.
Okay, I'll give as homework. Okay, part C. That's question 6, part C. Let's see now. Next one. Yeah, I'll just give you. Okay, let's do with question 2 now. Question 2, maybe I'll just go through one part. Maybe we can do it together. This is question 2. Let's do, part A. Then part B and C, maybe you can do it some more. Let's do part A together. You want to show that it is always positive. This time it's just changing the direction. More than 0. How?
Complete the square.
Okay, let's do that. Open bracket.
X plus 2k divided by 2. Then square.
Close bracket square.
Minus 2k divided by 2 square.
Yes.
Then copy paste.
The right side, the last two terms, right?
Yeah.
Let's simplify this. So 2k over 2, the 2's will cancel off. You're left with just a k. So x plus k bracket square minus away, same thing. cancel away the 2. You're left with a k inside the bracket, square, minus k square, plus 3k square plus 7. Then
equals x plus k square plus 2k square plus 7.
is this obviously more than 0?
Yeah.
Yes. Here, more than equal 0. Here,
Yeah.
more than equal 0. You times 2, k square is more than equal to 0. Anything square is more than equal to 0. But you times 2, it will still be more than or equal to 0. But then you have a plus 7. So worst case will be more than or equal to 7. Actually, which is strictly more than 0. Okay? Yeah. Okay, good. So proven. You wanna try more, or you want homework or anything? Okay.
Wait, so this part, right? Like
Which part? Yes.
This part, like where you're telling me like this part is more than or equal 0, and this part more than equal 0, then cos got 7, then this thing is always more than or equal to 7. How do I show the like working for that? Or like
okay. Formal yeah, I'm being lazy here. That's why I write it in this notation. Formal way, you have to draw a line, then separate. Then you just say, so it's just fact. Then you can also write down k square more than equal to 0. This is just a fact, right? Any value, these are just basic facts. Then if you times 2 to both sides, you get 2k square more than equal to 0. That's just multiplying by 2. Right? 0 times 2 is 0. K square times 2 is 2. But you multiply by positive, the direction doesn't change. Then maybe I can label this as inequality A, inequality B. And say inequality A plus inequality B gives me what? It gives me x plus k bracket square plus 2k square more than or equal to 0 plus 0, which is just 0. Then you need a plus 7 on both sides. So we add 7 to both sides of the inequality. So you realize that we are actually just working backwards.
okay.
Right? We work this way, but then in our presentation, we are sort of going backwards.
Okay.
Kind of. Then 0 plus 7 is just 7. So I will rewrite the
more than 0.
Yes, the left-hand side. Strictly more than or equal to 7, but 7 is more than 0 strictly. So therefore, we conclude that this guy must be more than 0. To be even more complete, this is not the original question, but we have already shown that these two are equal. So we can substitute back with the original expression. So this original guy is more than 0. Proven. Can? Actually, if you get this idea, you're not going for an exam, right? Don't need don't need. Just do this working, and then this final conclusion is good enough.
Okay.
Okay. Do you want to try part B or C? Or actually, can you if I want to decide, I'm going to assign B and C as homework, okay?
Okay, sure. Homework.
Then I move on to the new section so you can cover more.
Can.
Okay, can. Let's see. Second type of question. Okay, second type. We're still under section 6, by the way. Section 6. Second type of question. Show that the expression has no real roots, one root only, or two real and distinct roots. Show that let's see, look at part 3. Show that the quadratic expression has no real roots for all real values of k. Notice, this is again a show or proof question. Previously, we started off by telling you, okay, you got a quadratic here. It has two distinct roots. Then you immediately conclude b squared minus 4ac less than 0, and then or more than 0, sorry. Then you solve for some h or k, some constant. Now it's the other way around. We start off by giving you the equation. We want you to show for us that it has no real roots.
So show b squared minus 4ac is less than 0.
Yes, exactly. So let's just start off with the part A, the easy one. B squared minus 4ac in this case would be -4 squared minus 4 times 5 times -1, which happens to be 16 plus 20. Did I do something wrongly? Let me check out. Oh. This is wrong. This is 36, which is more than 0, which means that there are two distinct roots and real roots. Sorry. Let me just modify this a bit. I will change. Help me to change. Sorry. This should be a +1.
Okay.
Okay, this should be a +1. Okay, so it should actually be a plus pink color +1 here, and then we'll get a -20.
-4.
-4, and therefore
Less
no.
than.
Correct. Less than 0, and therefore no real roots. Good. Of course, if you want to show it has no real roots, a simpler alternative is that you can just use a quadratic formula and just solve this equation, right? And then you realize that you eventually need to square root a negative number, so no real roots. Right? You got quadratic formula minus b plus minus square root b square minus 4ac all over 2a. But this is the faster way, just check the b square minus 4ac.
Yeah.
Okay. Yeah. Okay. I hope I didn't mess up with the other questions. Let's try 3 part B. I'll transfer the working later. 3 part B. So how? Again, you must check your b square minus 4ac. So it will be what? I'll start you off. -4 square. Can you complete the rest? Tell me. Minus
4 times 7 times k square plus 1.
Yes. Simplify.
16 minus 28 k square minus 28. Then equals to -28 k square. Wait, actually.
What's wrong? Can.
Can, okay. Yeah, then minus 12.
Yes, 12. Can you factor out negative?
Yeah.
So you get 28k square plus 12. Can you tell that this is always negative?
Yeah.
Yes, because this part more than equals 0. You plus 12 means that this entire thing is more than or equal to 12.
Yeah, more than
which
0.
is more than 0. Then if you times negative?
Less than 0.
Less than 0, exactly. I'm just going to skip the working. I hope you can remember.
Okay.
I'll just write down working like this. More than equals 0. Then plus 12 become more than equal to 12, which is strictly more than 0. Negative times more than 0 become less than 0. Okay?
Okay.
Okay, good. Part C homework. Homework. Okay, try on your own. Okay, try on your own. The most difficult one give as homework. Sure. Now let's move to part 4. This one, 2 real and distinct roots. Okay, same thing. This time I think I really need to start on a worksheet already. Hold on a sec. Let me transfer the working. Okay, start new page. I need to find a new page. Hold on a sec. Okay, it's somewhere here. Okay, so yeah. Let me copy and paste this over. Okay, I think I'll just go through part. You know what? I'll go through the more difficult one. Parts. No. I'm going to go through part A and part D. Then this B and C will be your homework. Okay?
Okay.
Okay, let's see. So for part A, this one very easy. 3x squared minus 4x minus 11. You want to show that this guy has 2 real and distinct roots. Very simple. Just use quadratic formula and solve. But what's a more sophisticated way? You want to show it has 2 real and distinct roots.
Can you just do,
P squared minus 4ac. Show that it is
more than 0.
Exactly. So let's just check. You get 16. Negative times negative gives you positive. 4 times 3 times 11. I think by this stage you can tell it's positive already, right? You don't even need to find out what it is.
Yeah.
Right? Okay, done. Okay, and therefore 2 real and distinct roots. Okay, don't want part B, don't want part C. Let's try part D. Let me copy down the equation first. Okay, so you got this quadratic equation. You want to show that it has two real and distinct roots. What do you need to check? B square minus 4AC more than 0. So let's go. B square minus 4AC is? Can you tell me?
11 square minus 4 times 2k plus 5 times 2k negative 5.
Okay, can we conclude more than 0 straight away? And then we try to solve for k? Is that what we are doing? Solve for k. Correct?
Okay.
Wrong. No, do not do that. Do not solve for k. This is not the point of the question. The question is giving you for all real values of k. This is a proof question. You're not solving for k. If you try to solve this, the answer you get is all possible all k values work. Every value of k you sub in, this will always be more than 0. So there's no point. Be careful of that. We gave you for all real values of k already. You don't solve for k. You do not solve for k. You prove that the b squared minus 4ac is more than 0, and then conclude two real and distinct roots.
Okay.
Okay, so let's go. So this is a proof question, not so easy. So it's 1 to 1 minus away 4 times. I noticed something. A plus b times a minus b.
Yeah, a square minus b square. 4k square minus
5 square 25.
Yeah.
5 times 5 is 25, right? Okay. Distribute the minus, I get negative 16k square plus, plus 100. I might have done the question wrongly. Let me check again now. You know what? Let me just change this question format. Help me to edit on your question 3 and 4. Instead of show, I'm going to say determine whether the quadratic expression has no real roots or one root only or two real and distinct roots. Then I can save my question. Then I'm just going to remove this. This statement here, just copy and paste the same statement. Okay, so it's the same question, but this time I keep it vague, because I think I didn't prepare the question properly. It's not always two real and distinct roots. It may be 0 roots, 1 root, or 2 real and distinct roots. So our job is to determine which is the case.
Okay.
By checking the b squared minus 4ac. Okay, so let's look at part D. So what we have realized here is that we start off with our quadratic. We check the b squared minus 4ac, we get to this expression. Or let's just simplify a bit more, which is 221 minus 16k squared. Then the question is, will this have 0 roots, 1 root, or 2 real and distinct roots? Wait a minute. Maybe this question is not so well planned. Let me think a little bit. Ooh, let's analyze this. K squared is more than or equal to 0, so negative 16k squared is less than or equal to 0, correct? If you add on 221, what happens? It becomes less than or equal to 221. Right? So it could be that it's less than 0, equals to 0, or something in between. Something in between, more than 0. So b squared minus 0 less than b squared minus 4ac, or less than or equal to 221. So this is a very badly planned question. I'm so sorry. There is no solution to this one. Okay, and you know what? I'm a bit scared. Let me just double confirm. This one I probably shouldn't assign as homework. Let's just do it together now. Let's say we try part C. Okay, we try part C. Hope I didn't copy it wrongly. Didn't plan it wrongly. K minus 1 x squared plus 18x minus k minus 1 equals to 0. This is my part C. Okay, so we want to determine how many roots does it have. What should we do?
B squared minus 4ac.
Yes. So what is it equal to? 18 squared minus 4 times a times, what's a c here? Is it minus 1? Is it just minus 1?
What?
What is my c here? For a c.
If came -1.
Okay, very good. So let's just simplify this. 18 squared is, let's see, 324. Then we can distribute this. Okay, let's see. So I realized that there's a negative and negative here, so I can factor out a minus sign, right? Yes. So what I'll get is a negative in front, but this becomes k plus 1. So the negative will cancel off with this negative, or in other words, like this. The negative here and the negative here will cancel each other off. You're left with 324 plus 4 times k minus 1 times k plus 1. What's k minus 1 times k plus
1? K squared minus 1 square, which is just 1.
Yes, which is just 1. So remove the square. Then you can distribute 324 plus 4k squared minus 4. This is a better planned question. Okay. So let's simplify. 324 minus 4 is 320 plus 4k squared. What can you conclude?
Always going to be more than 0.
Yes, this is more than or equal to 320, which is more than 0. So therefore, how many roots?
2 real and distinct roots.
Yes. Okay, I will just assign part B as homework. Part B. I'll send you the homework list later. What questions to do? Okay, that's question 4. Let's move on. Next one. Now part 7. Finally reached the last part already. This one is the most common question that they'll test you on. So we are basically gonna look at that same diagram again I mentioned earlier today. This guy. Notice that I have been looking at the relationship between the graph and the x-axis. The quadratic graph, happy or sad face, versus the x-axis. But now what we're going to do is we're going to generalize it. Okay, generalize it. Meaning that we are no longer going to simply look at the x comparing with the x-axis, but we're going to compare with a straight line. We're going to change it into a y equal mx plus c. Okay, so let me just copy and paste this entire diagram. It will be exactly the same. Let me just add on one more slide page, something like that. If I can find the okay. So now we're gonna change it from our x-axis into y equals mx plus c. You remember this, right? Equation of a straight line.
Yeah.
Yeah. So what we're gonna do now is we're gonna look at the relationship between the quadratic curve with our straight line. So let me just draw in the straight line first. Then you'll understand what I'm saying already. Hey, wait, let me just remove this x-intercept. Remove away the x-intercept, distracting. And finally, so what do you see? What's the pattern?
In
Let's say
one
this one.
don't intersect.
They never touch each other at all. This one, the curve and the straight line. Intersect one time only. This one,
Intersect 2 times.
2 times. So instead of 0 roots, 1 root, and 2 roots, I'm gonna change it to intersections. This is the general version. Just copy and paste this. Why is it lagging so much? Yeah, so number of intersections, okay? And the table still holds. The table still holds. Whenever you have a happy face and then you have a b squared minus 4ac being less than 0, it means that they never touch each other. Like this. No intersection. 0 intersection. If it's exactly equal to 0, it's 1 intersection. If it's more than 0, it's 2 intersections. Okay? But actually, usually we would not be looking at the separation between the cases a less than 0 and a more than 0. We just need to focus on the relationship like this. 0 intersection, 0 intersection, 1 intersection, 2 intersection. The key is this part here, here, and here. B squared minus 4ac. Okay? Yeah. So yeah, I think it's better if I just go straight into the question, then you'll understand what I'm saying. So let's see. Yeah, this is a very common question. Always tested on. Let me copy down the question. My plan is to go through part A, B, and C, then D, E, F is your homework. Okay, let's take a look. So, yeah, part 7. Find the range of values of k given 2 equations that intersect each other 2 times, 1 time, or 0 times. Now, let's read the question. So, find the range of values of k for which the 2 graphs shown below have no point of intersection. It's also known as never touch each other, also known as 0 points of intersection. So what do you notice? You start off with this first equation, y equals 4x squared, blah, blah, blah. And on second equation, y equals minus x plus 3, your mx plus c. What are you supposed to do?
4x squared minus 4x minus 3k plus 5 equals to negative x plus 3.
Very good. Yes, that is the first most important step. You know this? First step, the most important one. Equate, or rather solve simultaneously. Sorry, I need to restart my app for a bit. Hold on.
Okay.
It's getting a bit slow. Hold on a second. Okay, Ken. Yes. What was I saying? Yes, the first step, the most important step, you need to solve them simultaneously. Sorry, my handwriting. Yeah, so you have y equals, so you can just equate them. Then, if you want to figure out you want to use the b squared minus 4ac, you do not just start off with the original quadratic and conclude your a, your b, and your c. Okay? You need to solve them such that you get to a standard form equals to 0. And then you get a corresponding quadratic. Then you identify your a, your b, your c. Okay? Okay, let's do that. So let me just drag it down. Let's simplify this. So minus x, bring it over. Plus 3, also bring it over. Minus bring over becomes plus. So what we will get is, I'll just copy and paste because I'm a bit lazy. Then minus x, bring over. Plus. Plus 3, bring over. Change to a minus sign. Equals to 0. Okay? Okay, oops. Then you just have to combine like terms. Minus 4 plus 1, minus 3x. plus 5 plus 5 minus 3, you get a plus 2. Don't forget the minus 3k in front and the 4x squared equals to 0. Now it is in the standard form, equals to 0. Must have standard form. Standard form. RHS, right hand side must be equal to 0. Then you conclude your b squared minus 4ac. It must be what?
It must be less than 0.
Yes, correct. No point of intersection, less than 0. Okay, so what would that be? It will be b squared minus 4 times a times c less than 0. Then you just solve for k. I think it's a standard procedure, right? You know how to solve already. So I'll go a little bit faster.
Yeah, sure.
Can, okay. Minus 3 squared is 9, minus away 4 times 4, 16. 16 multiply into minus 3k plus 2. Distribute. So negative times negative gives you positive, positive, let's see, 48k. Negative times positive gives you negative 32. 9. 9 minus 32, calculator. 9 minus 32, negative 23. 48k minus 23. Less than 0, less than 0, less than 0. You didn't multiply by negative 1, so you don't need to flip the sign. Solve for k. K less than 23 over 48. That is your answer. Okay?
Okay.
Good. Okay, next question. Let's try part B. Let me copy down the equation first. Y equals 3k plus 1 minus 2x squared minus 4x, and y equals x plus 2. Okay, so what are you supposed to do? The first step?
Equate.
Equate. Oh, maybe I should label this as second step. First step is equate. Second step is to solve them simultaneously. Sorry. First step is to equate or solve them simultaneously. Second step, you must convert into standard form. Right hand side must be a 0. So let's just do that. This is part B. Equate. So what do you get? Y equals, so you can just equate and you get 3k plus 1 minus 2x squared minus 4x equals to x plus 2. Correct?
Mm-hmm.
Okay, good. Standard form, how? Can you do it together? Can you tell me what to write?
Negative 2x square, then minus 5x,
Okay.
then plus 3k minus 1.
Yes, correct. 3k plus 1 minus 2 is just minus 1. Equals to 0. Right? Equals to 0. Okay? Then what do you conclude? This question is talking about no point of intersection between the curve and the straight line. So you need b squared minus 4ac
Less than 0.
for 0 point of intersection. I'll just call it POI. Then what do you get? Negative 5.
5x. I mean negative 5 square minus 4 times negative 2 times times 3k minus 1.
What is it? Less than 0, exactly. Then just simplify. Negative times negative gives you positive. 5 times 5 gives you 25. Minus 4 times negative 2 becomes positive 8 times 3k minus 1 less than 0. Then I can just bring the 25 over. So I get a negative 25. I divide by positive 8. So do I need to flip the sign? Flip the direction, sorry.
Divide, no.
Positive don't need, exactly. Then solve for k. So k must be less than, add 1 to both sides to get 3k, then you divide by 3. Yeah, then just use calculator. Let's see what it is. I think it's a negative 17 over 24. Right? Is that okay?
Mm-hmm.
Can okay, good. Okay, try one more. Do you want to try on your own? Maybe you write on paper and pen, then just take a photo and send me. Try this one, part C.
Okay.
Or is it inconvenient?
No, I'm okay. Anything.
Okay, yeah. Try writing. on your own. Let me drink some water. Yeah, once you're done, you take a photo and send me on Telegram.
Okay.
Thank you. Let me know when you send up.
Oh, I just sent it. Oh, I just sent it. Oh, I can't hear anything.
Oh my goodness, I was muted. Sorry. Okay, restart. Sorry. Oh my goodness, when did I? Okay. Let me restart. Yes, your working is perfect. I just checked it. It is perfectly fine. I did not even finish it in time, but yeah, your working is okay. Okay, believe. Yes, your working is perfectly fine. 16/60 is the correct answer. You can simplify into simpler terms. Okay. I don't go through because you got it already. Then now, mic test. Can you still hear me?
Yeah, I can hear you.
Okay, good. Sorry. Yes, that was for question 1. Then part D, E, F, I'll assign as homework. I'll type it in later. Don't worry. I'll tell you what homework to do. Then now let's just look at question 2 and 3. They are exactly the same. It's just that now I change it to 2 points of intersection, 1 point of intersection. Can you tell me quickly? B square minus 4AC, you want 2 points of intersection. What does it have to be? Less than 0, equal 0, or more than 0? More than 0. Yes. Only one?
Equals you.
Exactly. Then do you need me to go through?
I'm okay with anything.
Okay, can just important point to take note is that I'm trolling you here in the question 3 DE and F. I give you 29,999 and 30,000. The reason that I give this is to test some students, because I have some students who just cannot remember that you're supposed to equate the two equations. Then this is what they did. They just focus on this quadratic. Oh, quadratic, straight away ABC, then B squared minus YC. So they give me 102 squared minus 4 times 2H minus 1 times 29,999. Do you think this is right? Definitely not correct. The numbers are too big. That's not the point. You need to equate them and then rewrite into standard form. Right hand side must be equal to 0. Then you realize that 102 and 100, you'll just cancel off, your life with 2x only. 29,999 and 30,000, you'll cancel off to give you -1. So this one is actually -1. This one is actually just 2. Okay. If you manage to do that step, then you'll get it. If you never, you'll get this horrible expression with such a big number. Okay, that's the main point. Do you want me to go? Okay. I think I have time for only like one more question. Which one do you want me to go through? Maybe two more. Which one? Pick one. I restrict to ABC.
You pick.
I pick out. Okay, then I'll just go for part C and part C.
Okay.
All right, let's go through question 2, part C. Let me copy down the question first. So for question 2, part C, what did they say? You want to find the range of values of K for which the two graphs have 2 points of intersection, also known as cutting each other 2 times. Let me just paste it here. Oh, right, I think I should also, so far I've been giving you quadratic with linear. Actually, this works for any, sorry, I've been giving you a very special kind of quadratic that's known as a polynomial. Okay, integer powers. There are actually other kinds of equations that you can deal with. It doesn't have to be quadratic. It can be any curve. Later then I show you. Maybe I'll just go through question 2, part C first. Yeah. So first thing is you need to equate the two equations, right? So let me just copy down the equation first. Yeah, so first step is to equate them. Or solve it simultaneously. You have y, then you can just make them equal to each other. So this guy is equal to minus x plus 3. Simplify, I get minus x squared plus 2x. I bring the minus over, become a plus 1, so it's plus 3x. Plus 3, I bring over, become minus 3, so 5 minus 3 is plus 2. So minus 5k plus 2 equals to 0. Correct?
Yeah.
Should be correct, huh? Okay, good. Then you can use your b squared minus 4ac. So b squared minus 4, a is -1, c is minus 5k plus 2. What do we want? 2 points of intersection. So this must be more than 0. Okay, then just solve. So 3 squared is 9, minus 4 times -1 becomes a plus 4, multiply into minus 5k plus 2. More than 0. Distribute. So 9 minus 20k plus 8 more than 0. 9 plus 8, 17 minus 20k more than 0. Solve for k. I think it's let's see, less than 17 over 20. Right? Okay, let's do it step by step. Bring the minus 20k over. 17 more than 20k. I prefer my variable on the left side, so I swap them around. Then I divide by 20. Yeah, looks correct. Okay. Can?
Yeah.
Okay, let's try one question. Let me find the question first. Give me a second. Found it. Okay, the evil question. Question extra number 1. You can try I'll send you the homework question later. I'll just give you some extra questions. So this extra question is asking you to find. Oh wait, I should just screenshot for you. Hold on. It's from another one of my worksheets. I'll send it to you on Telegram. Have you received it?
Yeah.
11 and 12. Yeah, so let's just do 11 first. Yeah, I think I have time for this. Find the range of values of k such that the straight line y equal x minus k cuts the curve y equal kx squared plus 9x at two distinct points. So write down the two equation first. There was a semicolon here. What do you need to do first step?
Equate.
Yes, very good. Equate. Yeah, just remove this. So you just have to equate them. So k y equals to y, so kx squared plus 9x equal x minus k. Correct? Yes?
Yeah.
Then you just rewrite into standard form equals 0. So what is it? Kx squared plus 8x plus k equals to 0. Yes?
Yeah.
Okay, then what do you need? Cut each other at two distinct points.
B squared minus 4ac or more than 0.
Yeah, so it's b squared minus 4ac like this. Correct? Yes?
Yeah.
Okay, simplify 64 minus 4k squared more than 0. So question, this is a recap. Okay, let's say I divide by 4 first. 64 divided by 4. My brain is not working. What is it? 16 minus k squared. So let me show you a wrong way to do it first. I multiply by -1 on both sides. This is okay. And then I decide to bring the 16 over. And then I see k squared. So I take square root on both sides. Square root 16 plus minus, which is plus minus 4. Then I conclude k less than -4, k less than plus 4. Correct? Is this a way to solve this?
Probably not.
Yeah, definitely not. If you remember your section 1, the homework questions, you did it correctly already. You already know how to do this. The correct way to do it is not to bring the -16 over, is to factorize. So let's just multiply by -1 on both sides first. So this will be k squared minus 16 less than 0. Must flip the sign now. Then you can rewrite as minus 4 square, right? 16 can rewrite as 4 square. Then how? You need to factorize. What's k squared minus 4 square?
K plus 4k minus 4.
Exactly. If you never factorize, you cannot solve this inequality. Please remember, do not bring the constant over and take the square root. Wrong. This is wrong. You have to factorize. Factorize is the correct way. Factorize. Then again, k-axis, happy face. Why happy face? Positive coefficient. What are the two roots? -4 and +4. Less than 0, bottom part here. Not just the bottom part of the curve, you want the shadow. Imagine there's a torchlight. Imagine there's a torchlight shining. And then it casts a shadow on the floor. Then the shadow is your answer. So -4 less than k less than 4. Answer. Okay?
Okay.
Okay, good. That is extra question 11. Let's try another extra question 11. Extra question 12. Find the range of, you can see the question, right? I'll read it off from your phone. Yes?
Yeah.
Find the range of values of m for which the line y equals to 5 minus mx does not intersect the curve x squared plus y squared equals to 16. This is challenging. Notice now that this is not a standard quadratic curve anymore. This is actually the equation of a circle. Have you seen it before?
No.
Okay, I show you. Wait. Let me find it first. If I can just share screen. Yeah. Okay, so x squared plus y squared equals 16. This is unique. This is only in Amax. Emax you never learned before. This is called the equation of a circle. Can you see? What's so special? What's the radius of this circle?
Radius is 4.
4. What's so special about 16? How is it related to 4?
4 square.
4 square, exactly. Do you notice the center? What is it? Coordinates.
0.
0, comma 0. Let's say I change this x. I put down -1. What do you notice?
Center change
Center
to
change to what?
-1.
No. Look at the picture. Look at the picture. Where's the
1.
it's 1. Whenever it's a -1 here, it changes to a +1. You notice the pattern?
Okay.
Yeah, so that's a pattern. This one is something that actually you will learn in AMAX later, next few weeks, and I talk about it. Okay. Okay, anyways, the question is asking you, you got this, okay, the x squared plus y squared equal to 4, and then you have this y equals to 5 minus mx, where the m can be any number. You see, when I change the m, right, notice I can turn it around like this. Maybe I should have done this for all the other questions too. This is the picture. This is the picture way of what we are discussing. You see, as you change the value of m, you notice the graph, the blue color line, it just changes around, right? Yes? Then what we are interested in is what is the range of values of m such that they never touch each other. You see, this one, how many times does it touch each other? It cuts each other 2 times. Blue and red cut each other 2 times. But if I just increase the value of m a little bit to, like, let's say negative 0.8, currently m is negative 0.8, meaning you get y equal 5 plus 0.8x. You will cut each other 2 times. But if I can just change the step size a little bit. Oh, that's a bit too fast. You notice that if I keep on increasing the value of the gradient by, let's say, I don't know, different values, 79, 0.79, 0.78, 0.77, 0.76. You notice that these 2 points here, they are moving closer and closer towards each other. Okay, maybe it's better if I do this. Let's see, negative 0.8, negative 0.75, and then the step size 0.001. Oh, sorry, let me change this to a negative sign first. You see, can you see? As I change the value of m, right, the blue line is moving. And there are 2 intersections with the, what do you call it, with the curve. Can you see those 2 gray points that are moving?
Yeah.
So they are moving further away or they are moving closer towards each other. So we are interested in what values of m will allow us to have the blue curve to never touch the red curve, right? No point of intersection.
Yeah.
That's a bit challenging, right? You can't just guess and check, right? You guess and check all these different m, impossible, right? So that's why we need this whatever I'm teaching you today, the b square minus 4ac trick. Okay, so what we're interested in is the correct value of m such that the blue color line it is not touching the red circle. Okay, not touching the red circle. So yeah, let's just see one more time. We check the different values of m and the blue color line. You notice that there are certain particular values of m where it cuts the curve 2 times, cuts the curve 1 time, or cuts the curve 0 times. Like for example here, like when it's 0, it doesn't touch the circle at all. So this is 0. So m equals 0 is one of our possible answers. But we actually need the full range of values of m. And that's when we need the theory. Okay, guess and check is not good enough. Is that okay? The intuition?
Yeah.
Okay, now we do the math, the algebra. Let me share my screen. So again, it's the same procedure. First step, you always equate or solve simultaneously. So maybe I can call this equation 1, equation 2. Notice that I have a y here and a y here. What I can do is I can say sub 1 into 2, simultaneous equation. Okay, so what do I get? X squared plus what square equals 16? What's inside?
Oh,
5 minus mx. Correct? Sorry, I complete this last question before we call your day. Is that okay?
yeah, no, that's okay.
Can I? Yeah. So x squared plus 5 minus mx, right? You see, I just replace this y with 5 minus mx.
Okay.
Then now I have a quadratic equation. What can I do? Simplify into standard form. Same procedure again. Blah, blah, blah equals 0. So let's do that. Let's do that. So expanding this, I get x squared plus 25 minus 2 times 5 times m is 10m x plus m square x square. Is that okay?
Yeah. Wait.
Equals 60. Sorry?
Yeah.
Okay, good. Then I noticed that here got 1x squared. Here got m square x square. What can I do?
M square plus 1 x square.
Yeah, with brackets, exactly. Then minus 10mx plus 25 equals 16. Oh, I can bring the 16 over so it becomes a 9, right? 25 minus 16 is 9. Yes?
Yep.
Equals 0. Okay, standard form reached. Right hand side equals to 0. Good. What can we do now? Identify our A, our B. Is it negative 10 or is it negative 10m? Our B.
M.
10m. Good. And our C, which is 9. So what was the question saying? We wanted no point of intersection, right? So what do you know about B squared minus 4AC?
B square minus 4ac or less than 0.
No point of intersection. Okay, can. Then we can just sub in the formula. Negative 10m squared minus 4 times A times C less than 0. And just solve for M. You see, if you actually try to guess and check, you're never going to get the correct answer. That's why you need this. That's why you need this trick. Okay, so negative times negative gives me positive. 10 square is 100. M square is just M square. Okay, 4 times 9 is 36. So minus 36. Bracket M square plus 1. Less than 0. Distribute. I get minus 36 M square minus 36 less than 0. Yes?
Can.
So you get 64 M square minus 36 less than 0. I think I can divide by, is it 18? No, not really. Divide by 2 lah. So 32 M square minus 18 less than 0. How to solve? Do you bring the minus 18 over and then you square root?
No.
You have to factorize. So here is how I would do it. Square root 32m bracket square minus square root 18 square less than 0. Can? This part okay?
Okay.
Okay, then you just get a square minus b square. So a plus b times a minus b less than 0. Positive coefficient of m. So you can draw a happy face. The first root will be, let's see what it is. I think it will be a negative square root 18 over square root 32. The other one will be positive square root 18 over square root 32. Then less than 0. Which part of the curve? Bottom part. Then you find the shadow. So the answer is negative square root 18 over square root 32 less than m less than the positive. Can? Let's simplify this. 18 is really just what is it? 9 times 2. So square root 18 is the same as square root 9 times 2, correct? Yes.
Yeah.
Good. Okay, good. Then you can split it out as square root 9 times square root 2. What's so special about square root 9?
3.
So it's 3 root 2. This is a topic called surds, which is also in AMAX. It will be dealt with later. Basically, the formula you need to remember is square root a times b is square root a times square root b. You learned this in Emacs before, right? In surds. It's just that you never see this particular formula. And square root a over b is square root a over square root b. Remember, like A times B power m is A power m times B power m. Yes?
Yeah.
It's just that this case I replace my m with a 1/2. And 1/2 is just square root. So square root. Right? It's just a special case. Likewise for the what's the other formula? The A over B power m. It's just A power m over B power m. Okay? I just replace the m with a 1/2. Then you have to know these two formulas, the special case. Okay, anyways, still got a bit more. Square root 32. You realize that it's actually the same as 16 times 2, correct?
Mm-hmm.
Then you can split as square root 16 square root 2, which is 4 root 2 exactly. So we can simplify this as 3 root 2, negative sign in front, over 4 root 2. And the other guy is, yeah, it's the same thing, 3 root 2 over 4 root 2. Anything to cancel?
Root 2.
Square root 2 can cancel off. It's just a number, 1.414, blah, blah, blah. But they are exactly the same, so we can cancel them off. So the actual answer is negative 3/4 less than m less than positive 3/4. Beautiful. Understand?
Yeah.
Okay, let me just do one more extra thing. I'm just gonna show you on the diagram. Let's say negative 3/4 and positive 3/4. Let me just decrease the step size to 0.1. Let's take a look. Do you agree with this answer and the picture? You see, as I change my value of m in between negative 3/4 and positive 3/4, which is 0.75, 3/4, you notice that it never touches the circle.
Yeah.
The only time when it does touch is when it's exactly equal to 3/4. It's what we call a tangent. You see?
Yeah.
It touches only 1 point. Okay. Yeah, so that's it for today. I'll give you the homework later. Any questions?
No.
Okay. Okay. Yeah.
I don't know if you could tell, but I got very tired at the end.
Okay. Yes, I got it. But
That's why. That's
yeah,
why.
so
Yeah.
yeah, don't worry. The questions, this is a very difficult question. The homework I give you not that difficult. So yeah, you can try that.
Okay.
Can. Okay, that's all.
Okay. Thanks.
Okay, thank you.